Trig function problems. In this video we're going to explore some more challenging problems using SOHCAHTOA. You can familiarize yourself with the equations here. Solve for the variables round to the nearest tenth. Example 1. So here we have an isosceles triangle with a bisected segment which is perpendicular to the base side of the isosceles triangle. And we know that isosceles triangles have congruent base angles, so therefore angle Z is 37. Okay, so what else is going on here? I have this isosceles triangle and this segment that is perpendicular to the base. So these two other smaller triangles that make up the isosceles triangle must also be congruent because of the hypotenuse leg theorem. So therefore we know x is 6 inches. Now to find y we can use tangent equals opposite leg over adjacent leg. So tangent of 37 equals y over 6. We have to multiply 6 to both sides to solve for y. 6 tangent of 37 degrees. I'll go to my calculator, make sure that I'm in degrees, not radians, and I get 4.5 inches. Now we can find w. We could use Pythagorean theorem or sine, but cosine is going to be more accurate because we're using a given number, not a rounded number like 4.5. We need to solve for w by multiplying it to both sides to get it in the numerator, divide cosine 37 to both sides, and I get w equals 7.5 inches. Box in our answers and we're done. Example 2. So this time we have a right triangle with another little right triangle inside, and we're looking for x and y. We have to find x before we get y, and we can do this by using tangent. Again, I need to multiply x to both sides to get it in the numerator, and then divide both sides by tangent 62. I get x equals 8 centimeters when I round it. Now we can find y. So tangent of 28 degrees equals opposite, which is 15, over adjacent, which is x plus y. Well, x is 8. So I need to multiply 8 plus y to both sides to get that y part in the numerator. And then I can divide tangent 28 to both sides. Now here I could have distributed the tangent 28 into the 8 and the y, but that might be a little difficult in the long run. So we'll divide by tangent 28 and then we'll subtract 8 to both sides. I can put this in my calculator and I get 20.2 centimeters when I round to the nearest tenth. So there we go. We found x and y. Example 3. This time I have a right triangle with a segment that cuts that right triangle into two other right triangles. I'm looking for angles y, z, sides x, and w. So the first thing I need to do is find angle y, and I have a side opposite and the hypotenuse. So I can use the inverse sign to find the angle y. Whenever we're looking for an angle, we need to use the inverse. So 36.9 degrees is y. Now I can find everything now, x, y, or angle z. I'll go for x using the tangent. And we get 15.0 inches. We can find w now. We could use Pythagorean theorem, or we could use sine or cosine. We'll go with cosine. If we use cosine, it's a little bit easier because the unknown w is in the numerator, not in the denominator that it would be for tangent. Now for z, we could use sine z equals 12 over 15, but we know that the angles of a triangle add up to be 180 degrees. So we can just subtract 36.9 and 90 from 180, and we get 53.1. Notice that all these triangles are similar. So here are some practice problems on the right that are very similar to the ones that we just did. So pause now and take a shot at it.